In this session, we're going to cover the context calculation capabilities in Pyramid. Context calculations are very powerful capabilities that allow calculations to be defined in the context of the report that they're included in. This is distinctly different from semantic calculations, which are calculations and business logic that is created in the context of the model without any concern for how a particular report is designed and the different data elements included in that report. To demonstrate this functionality, we're going to start with this very simple example on screen. As the first thing that we're going to do, I'm going to right click on sales, which is what you're seeing here on the grid, and turn it into a show as, choose context calculations, and then choose percent of total. Immediately you can see that we've changed the calculation now into the percentage of total sales shown by manufacturer, female and male. And if I go ahead and add grand totals, we can see the impact across the entire grid. The reason this is a context calculation is because the definition of sales here is calculated as the total for female and male by manufacturer as the denominator, with every cell being the numerator. If I go ahead now and I decide to remove Acme, I've removed it from the equation, yet the whole grid again still accounts to 100%. Another example of the context nature of this is I tag marital status and I turn onto the columns. The calculations here again represent the atomic level of cells for each cell in the grid, but the whole thing continuously adds up to 100%. In the next example that demonstrates context calculations, I'm going to right click on sales, and this time I'm going to choose create. This creates a new chip with the calculation. In this situation, I would like to create a cumulative total chip. By doing that, it adds a brand new calculation called total sales, which is accumulating across manufacturers down the columns. What's interesting here is that the definition of the accumulation, although this is specific to manufacturers, is completely fluid. That means if I chose another chip and I threw it onto rows here, the accumulation will still work, even though the definitional point for how you accumulate things has now changed to manufacturers and marital status instead of just manufacturers. So much so that if I was to change the structure of the grid, it still continues to work. And in this case, we're looking at cumulative sales by marital status and gender across manufacturers. The way the accumulation works in this particular case is based on the position of the values chip when it comes to a grid. Because the values are posted here on the columns, the accumulation is going to work down the rows. If I was to drag the values chip to the rows, the accumulation is going to work across the columns. This is a really clever way for solving the way the accumulation should work by simply placing the values chip in the right drop zone. If I removed sales and I removed the values chip, the accumulation will snake its way through the data, ultimately accumulating down to the last cell in the grid. So that if I chose the total sales, you can see that the final cell in the grid, $13 million of sales, and the grand total for the entire grid is also $13 million in sales. The next capability that is available through Context Calcs is to right click on an orange chip again and choose a different aggregate. In this case, I would like to see the average sales broken out between male and female by manufacturer. The reason this is contextual is because when I change the definition of the query, the average sales for each particular cell is going to change accordingly. This is not that different from doing it as a semantic calculation, just a whole lot more convenient. In the next example, we're going to focus on using context calculations to do advanced charting. Here I'm looking at subcategories of products on the categories of this chart, sliced by categories. This allows me to see each of the subcategories for a product. Let's go ahead, create off the sales chip the Pareto calculation, which is the same as a cumulative total, just expressed as a percentage. And you can see it automatically creates two charts on the screen. One is the actual sales and the second is the cumulative sales total using Pareto analysis. Instead of doing two charts, I will use the Pareto to create a secondary line chart on the primary chart, swapping the chips around to put the Pareto on top, and suddenly I have a classic Pareto analysis for product categories. And what's nice is I can now trellis this, slice and dice it in like any other calculation in the product to produce different kinds of analyses as I need. In the last example of context calculations, we're going to look at the chart showing sales by quarter. One of the interesting things to do is to see the differential move in sales quarter on quarter. For that, I'm going to go ahead, choose create, context calculation, and choose difference from previous, which is going to calculate each quarter's difference from the prior quarter and show that on a chart here using the new metric previous sales. What's nice is that I can use this new numerical calculation as a way to color sales itself rather than as a chart in its own right, and in this regard I can show numbers that are reducing as red and numbers that are increasing as in green. The context value of this is that if I change quarters and I was instead going to use something like months, the definition for the values is going to change, including the way the previous sales calculation itself is going to change. In this case, it's going to be the movement month on month. This is a fantastic example of how context calculations can solve classically complicated problems with all your visualizations that are otherwise hard to do with semantic or database calculations.